Our next normal form is Griba normal form. What this says is any context-free grammar not accepting epsilon can be expressed like this, meaning each production in CFG has this type. A implies small a, which is a terminal, and followed by alpha. Alpha is a string over non-terminals. For example, you say S imply small a, this is in GNF because it is of this form. Or you say S implies A, S implies A, S, capital A, B, then this is in GNF. If you say S imply BC and S imply C, then this is not in GNF, but this is in CNF. So this clearly tells you that a CNF formula, and if it has production of exactly this type, then it is in GNF, otherwise it is not. For example, S implies D, this is in CNF, it is also in GNF. The moment you have a non-terminal like this, then this one is in CNF but not in GNF. Now the question is the following. So far what is that we have seen? Given an arbitrary CFG, one can simplify CFG, meaning by removing epsilon productions and unit productions, symbols that are not reachable, all that. On the simplified CFG, assuming it is not accepting epsilon, one can come up with the CNF. Now what we will do is, we will convert CNF to GNF. You can always convert an arbitrary CFG to GNF, but because having seen this, what we will do is we will assume the input is in CNF and we will convert CNF to GNF. But one can always convert CFG to GNF directly. Okay, let's see the procedure, and using which we will convert a CNF to GNF. As always, the input to this, the language is not accepting epsilon. Similarly, for this also, the language is not accepting epsilon. Okay. Remember, if we get a production like say A implies BC and say B implies D, one simple procedure is one can say A implies, substitute D for B, then we get DC, B implies D. Now you see that this one is in CNF but not in GNF. With this simple substitution, we see that this one is in GNF. Alphabet followed by a string of non-terminals. Alphabet followed by string of non-terminals. In this case it is 0, in this case it is 1. Okay, now this is precisely what we will be doing when we convert CNF to GNF. So if we have something like S imply AS and S imply SS, A implies BC, and then say B implies D, C implies small c. So what we will do is we will try simplifying this by substituting B implies D over here. Then what will happen? This will become A implies DC, and so these three will be in GNF, and subsequently we will substitute the value of A over here so that this S becomes A implies alpha, and then we substitute the value of S over here. So which means one has to come up with a systematic procedure, a systematic way of approaching the given grammar to obtain GNF. Fine. So what we will do is we will work with A1, A2, A3, so on up to AK. Instead of S, A, B, C and so on, we will work with A1, A2, AK, and with that we will come up with an algorithm, and if you strictly follow that algorithm, we will obtain GNF for a given CNF. Why do you need to go for this kind of replacement? See, one has to be careful when we apply the procedure that we just now outlined. From this, we get A implies DC and S implies, now the current value of A is DC, so we get DCS. Now S implies SS. Okay, so now for S, if you see, you get to see S imply DCS and also S implies SS. Okay, so you may substitute DCS for this, but that is only one substitution, but you still have S imply SS. Correct? For example, from this, when you move to the next step, we will have S imply SS and S imply DCSS. For the first S, I am substituting this. Okay, so this will still be there. This is only one branch that says S imply DCSS. Okay, so what is this telling us? A simple substitution like this, looking at the variable and substituting the appropriate production, may not give us Griba normal form always. The best example is this. We kind of get into a cyclic argument, you keep seeing S imply SS. Okay, we can't get rid of this S imply SS just by substituting S imply DCS once. Okay, so when we have grammar like this, which is clearly in CNF, how do we come up with GNF? So a simple substitution may not give us GNF always, so we need a sophisticated technique to handle grammars of this type. We shall take a specific example and we experiment our procedure through that example. On the fly, you get to understand why these modifications are done. For example, a production is replaced by a couple of or set of productions, and why is this modification done, and how is this will eventually give us Griba normal form. All that you can appreciate on the fly. Let's take an example and experiment. So consider this grammar. A1 implies A2 A3, A2 implies A3 A1 or B, A3 implies A1 A2 or A. A and B are terminals, A1, A2, A3, they are non-terminals. Now if you look at this, A2 implies B or A3 implies A, they respect this, but these three, they do not respect GNF property. Therefore, we want to rewrite this following this procedure. Okay, so this is applicable for each production. So the first rule says you find a production AK implies AJ alpha. See, I have rewritten the variables using A1, A2, A3 so that you will appreciate this procedure in a better way, and it is easier for us to apply when it comes to problems. So given a problem with S, A, B, C and so on, you always rewrite using the variables A1 to AK so that you can invoke these rules pretty easily. So the first rule says you find AK implies AJ alpha where J is strictly less than K. So on this side you find a smaller index. Then what it says is for all productions AJ implies beta. Beta is a string over terminals and non-terminals. So beta could be any string. And you find production of this type and substitute over here. AK implies beta alpha. This should be done for each AJ implies beta. If there are 5 productions starting with AJ, and you will get 5 productions which says AK implies something. And once you substitute all possible values for AJ, you remove this. Okay, so let's apply rule 1 for this example. How long you will do it? You will continue to do it until you find a variable whose index is at least this. Correct? Once it is more, you stop. Correct? Then you start seeing whether rule 2 and rule 3 must be applied or not. And when it is equal, AK implies AK, then one should bring rule 2. And when you have AK implies beta, where beta does not begin with AK, then you apply rule 3. Okay. So look at a production. If the start symbol on the right has lower index, then use this replacement rule. You keep doing this until some point you will get a variable whose index is larger than this. Then you stop, or if it is same, you stop. If it is same, then you go for rule 2 and rule 3. That's all. Now let's look at this. If you take K to be 1 and AK implies AJ alpha, but this index is larger than this index, then rule 1 is not applicable. If you take K to be 2, then you see that this index is larger. So even for this, rule 1 is not applicable. Look at this. If you take K to be 3, now this index is smaller than 3. Therefore, apply rule 1 for A3 implies A1, A2. So the rule says identify all productions that begin with A1, and in place of A1 you place that. So we get A3 implies, in place of A1 we write A2, A3 followed by A2. Fine. The rest remains the same, and we remove this production. So A3 implies this or this, and A2 implies A3, A1 or B, and A1 implies A2, A3. Fine. So we look at this production which is violating, meaning A3 implies A1, so which means rule 1 is applicable. Rule 1 says find all productions starting with A1 and substitute the value of A1 implies in place of A1 here. So we get A3 implies A2, A3, A2, are A and the other two are as it is. Fine. Now, after applying rule 1, you check whether do we need to apply again. And as always, these two we do not need to apply. But look at this. After the first application of rule 1, we see that the modified production is still violating this. So, which means we should apply rule 1 again. Apply rule 1 for A3 implies A2, A3, A2. Now it says you find all productions starting with AJ and substitute over here, which means you get A3 implies A3, A1, A3, A2, or A3 implies A2 implies B. So we get B, A3, A2. Okay. Now in addition to this, we also get other two. So we get A2 implies A3, A1 or B, and A1 implies A2, A3. Fine. Now look at this one. This clearly says A3 implies A3 or A3 implies B, A3, A2, which means this is in GNF. A2 implies B, this is in GNF. And A2, A3, A1 no. A1 implies A2, A3 no. A3 implies this no. Fine. So to start with, we check whether A1 is violating and A2 is violating, A3 is violating. So we look at possible values for K, 1, 2, 3 and so on. And the moment you find a production whose first symbol on the right as index which is smaller than K, you invoke rule 1. Find all those productions of this type and go for replacement. How long you do it? Until you will see AK implies AK prime, where K prime is at least K. And the moment you find that, you stop. Now, rule 1 is no longer applicable, but now we have AK implies AK. The current value of K is 3, right? So AK implies AK, which means rule 2 is applicable. So rule 2 is applicable for A3 implies A3, A1, A3, A2. Fine. What rule 2 says is AK implies AK alpha. Alpha is a string over non-terminals, right? So this is our alpha. Current value of K is 3. So which means AK implies AK alpha. What it says is you introduce a new variable called BK and add productions BK implies alpha and BK implies alpha BK. Okay, and remove this production. Fine, let's do that. So what it says is you introduce a variable called BK. So in this case it is B3. So B3 implies alpha, which means A1, A3, A2, and B3 implies alpha BK, which means A1, A3, A2 followed by B3. Fine. If you look at this one is not of this type. So we find only one production of this type. If there are more, then for all of them, we should follow this rule. Okay, so we do this and we remove what? We remove A3 implies A3, A1, A3, A2. Fine. So now the resultant one will have this one, and this one, and this one. So first we applied rule 1 as many times as we can until you get to see AK implies AK prime, where K prime is at least K. At that point we stop. And you check whether this rule is applicable. And interestingly, for this one, we get to see A3 implies A3 alpha, and we invoke rule 2. Rule 2 says introduce BK implies alpha and BK implies alpha BK and remove this. Now, rule 3 says if you find AK implies beta, where beta does not begin with AK. For example, in this case, it is AK implies beta and beta does not begin with this. Then it says you write AK implies beta BK. So which means you get A3 implies B, A3, A2 followed by B3. So you add this production which says B beta, so which is B A3 A2 followed by BK, which is this. Okay. Now let me consolidate and write over here so that we can proceed with the next set of tasks. Note that we also have A3 implies A. Okay, so we were only modifying this part. We also have A3 implies A. So which means this rule is applicable for this as well. So you get A3 implies A B3. And when you apply rule 3, we are not removing anything. So which means A3 implies A will still be there. Similarly, A3 implies B, A3, A2 will still be there. Okay, so for this alone, this one is removed and we introduce B3 implies alpha and B3 implies alpha B3. And rule 3 says if you find AK implies beta, where beta does not begin with AK, then you add AK implies beta BK. Okay, so beta BK, and this should be done for each. So which means even for A3 implies A, we should add A3 implies AB3. And in rule 3, we are not removing anything. So which means this rule will be there and A3 implies A will also be there. Okay. So now let's consolidate and see whether the resultant expression is in Griba normal form. If not, how do we proceed further?